Hello everyone. In this video, I'm going to continue to use the reference 1 to 5 to do some examples for you. In example 6, you have two chords AB and CD, and BE is the diameter which is perpendicular to CD, and M is a point on AB, so that OM is perpendicular to AB, and the line BE cuts CD at N. And you have some lengths given. Part A. You need to find the length of OM. To find the length of OM, you should know that the chord A, B, and C, D are of the same length. Okay, it's given here. They are of the same length. That means you can obtain information of AB from CD, because you know that there's 4 here and you have 10 here, so you know that ON is 6. And since AB and CD are of the same length, then OM should be equal to ON. Now, find the length of ON first. Part A. OE is equal to OB is equal to 10 cm, which is the radii, and OE is ON plus NE, which is 4, so ON is 6 cm. And now, since A boy is equal to C dot, which is given, then we will have OM equals ON. Okay, and its reference is equal chord, equidistant from center. And that is OM is 6 cm. Okay. Now part B, find the length of AB. To find the length of AB is the same as to find the length of AM or MB and multiplied by 2, because you have the perpendicular line here. So, and you know OM is 6 now, so you can use the Pythagoras theorem to find the length of BM. Now, find the length of BM first. Okay, in triangle OBM, we have MB square plus OM square equals OB square. And then MB is actually 8 cm. Now, you know that since OM is perpendicular to AB, which is given, so AM is equal to MB equals 8 cm is the perpendicular joining center, joining from center to chord, bisects chord. Okay, and that is AB is the sum of these two, which is 16 cm. Okay. Now the last example for references 1 to 5. Example 7, you have two straight lines, AED and AB, and AC is the diameter. Is it? AB is perpendicular to BC here, and OM is ON. And of course, O is the center of circle. Without any specification, O automatically is the center of circle. OM is perpendicular to AB, and ON is perpendicular to AE, and A boy is perpendicular to BC. A boy is 12, BC is 4, and CD is 5. So we have 4 here, 5 here, and AB is 12. Okay, we have several Pythagoras theorem can be used. We can consider triangle ABC, and we can also find AD. Okay, but for part A, since OM is equal to ON, then we know that the length of AB is the same as that of AE. And so for part A, we don't need this kind of length first, okay, except this 12 cm. Now, since OM is ON, which is given, then A boy equals to AE equals 12 cm. Okay, the reference is chord equidistant from center are equal. Okay, so that is AE is 12 cm. This is part A. Now part B, find the length of DE. You should have experienced that to find the length of this kind of portion, you need to use addition of two lengths or subtraction of lengths. And also in part A, you find the length of AE, which is something related to the line segment DE. So you may need to use it. Okay, in triangle A boy dot, you have all the things except DE, so you can find the length of DE like this. Okay, in triangle A boy dot, we have AD square equals A boy square plus boy dot square. Okay, and A dot is formed by AE plus E dot, and AB is 12 square, and boy dot is boy C plus CD, which is actually 4 plus 5, that is 9. So AE plus ED is actually 15 minus 12, so you will get DE is 3 cm. Okay, so that's all for the examples for reference 1 to 5. I hope you remember most of them and use it properly. Okay, and there are more circle properties coming up. Stay tuned and thanks for watching.